we're going to continue writing equations of lines in slope-intercept form, but this time for your special lines, the ones that are parallel and perpendicular. In Algebra 1, you learned that parallel lines never intersect and they have the same slope. So if one of them has a slope of 2/9, so does the other one. Perpendicular lines have slopes that are opposite or negative reciprocals. In other words, you change the sign and you flip the fraction. So like here, if the slope is positive, we make it negative. If it's 4/1, you flip it to 1/4. So you change the sign and flip the fraction. So let's go ahead and look at an example here. This one says write the equation of a line that's parallel. So our keyword's parallel to y equals negative 5/4 x plus 3 and has a y-intercept of negative 2. So my first thing I have to do is look at my equation. I'm going to look at my slope only, negative 5/4. If it's parallel, the slope is the same. So I know that my slope is also going to be negative 5/4. And here they said the y-intercept's negative 2. That's my b. So here we have our slope and our y-intercept. So if we plug into y equals mx plus b, our equation is y equals negative 5/4 x minus 2. Our next problem here says write the equation of a line that passes through 8, 2. Remember, they give you a point that's an x1, y1. And then it says is perpendicular to y equals negative 1/2 x plus 3. So I have to look at the slope here, which is negative 1/2. But if it's perpendicular, I need to do the opposite or negative reciprocal. So if this one's negative 1/2, my new one's going to be positive. And then you flip it. So instead of 1/2, it becomes 2/1. Positive 2/1 is just equal to positive 2. So I know my perpendicular slope is 2, and I know a point. Since I know a slope and a point, I will use point-slope form. And I'm going to plug in for my y1, my m, and my x1. So I have y minus 2 equals, our slope was also 2 times x minus x1 is 8. I can distribute, so I get 2x, 2 times negative 8 is negative 16. And my last step would be to add 2 to both sides. So I get y equals 2x minus 14 as my equation in slope-intercept form. Here in this next problem, it says the line passes through 9, negative 2. So that is my x1 and my y1. And then it says it's parallel to the line that passes through 4, 5, and 7, 3. So this question, they gave me the point that our new line goes through, but they gave me 2 points that the line that it's parallel goes to. So I'm going to have to use these 2 points to find the slope and then see what a parallel slope would be. So this would be my x1, y1, and x2, y2 for the parallel line. So I'm going to have to use my slope formula. If I plug in for y2 minus y1, I get 3 minus 5. For x2 minus x1, I do 7 minus 4. This comes out to negative 2/3. And since it said parallel, I know my slope is the same. So my slope is also going to be negative 2/3. So now that I know my slope, and I know the point that the new line goes through, I can use point-slope form. So I'm just going to organize my information here. The slope of the parallel line, m, is negative 2/3. And the point that this line goes through is 9, negative 2. So that's my x1, y1. So now I can use point-slope form. So I have y minus, y1 is negative 2. My slope is negative 2/3. Then x minus, x1 is 9. Here, since I have a double negative, I'm going to change it to plus. So I have y plus 2 equals negative 2/3 x. Negative 2/3 times negative 9 is going to become positive. 2 times 9 is 18. If you divide by 3, you get 6. And my last step would be to subtract 2 from both sides. So I get y equals negative 2/3 x. 6 minus 2 is positive 4. And that would be my equation in slope-intercept form for the parallel line. Our last question here says that the line is perpendicular to 3x minus 2. So here I would look at my slope. It's 3. And I want a perpendicular slope to 3. So if this is positive 3, my perpendicular slope would be negative. I like to write it as a fraction. So 3, you can put it over an imaginary 1. The perpendicular slope, if you flip it now, would be negative, and 3 over 1 switches to 1/3. So the original slope was positive 3 over 1. The perpendicular slope would be negative 1/3. And here they gave me the point that the line goes through. So that's my x1, y1. Now I can use point slope form. So I have y minus 5 equals negative 1/3 x minus 12. I can distribute. Negative 1/3 times negative 12 is going to be positive 4. And my last step would be to add 5 to both sides. So I get y equals negative 1/3 x plus 9 as my equation in slope-intercept form. So to summarize, this is just what we were doing in the previous lesson. If they say parallel, then your slope's going to stay the same. If they say perpendicular, then you need to change the sign and flip the fraction. If it's perpendicular and your original slope is a whole number, you can put it over an imaginary 1. So like here it was 3 over an imaginary 1. When you flip it, becomes 1/3.